Let's practice solving problems involving fractions and multiplying. This is multiply fractions. And let's take a look at number 1. So we have 7 1/5 multiplying 1 1/4. What's so great about multiplying fractions is that it doesn't matter if the denominators don't match, but we do need to turn these fractions into improper fractions. How do we do that? We do whole number times denominator plus the numerator. Again, that's whole number times denominator plus the numerator. And then the denominator will stay the same. Let me show you what I mean. So 7 times 5 is 35. And then 35 plus 1 makes 36. So that's 36 over 5 times 1 times 4 is 4, plus 1 more makes 5. So 5 over 4. Now we can simplify before we multiply, meaning that if you have the same number diagonal from itself, or if you have the same number in the numerator and denominator spot, like in the same fraction, then you can simplify that down all the way to 1. So that becomes 1 and that becomes 1. Now I know my 4's multiples, and I know that 36 is one of them. So I know I can divide both of these by 4. 4 divided by 4 is 1, and 36 divided by 4 is 9. And now I can multiply straight across. 9 times 1 is 9, and 1 times 1 is 1. Now, any number on top of 1, we can just get rid of that and write it as this. Why? Because 9 divided by 1 equals 9. Remember that fractions are division problems. Okay, let's take a look now at number 2. I'll write it right here. Number 2 says 7/9 times 2 6/7. Go ahead and say it. I know you want to. Now, 2 times 7 plus 6. And remember, this fraction we don't need to change because it's already as, a numerator and denominator. The fact that this has a number in front of it is why we have to change it. So that's 7 over 9 still. And then 2 times 7 is 14. 14 plus 6 is 20. So that's 20 on top of 7. Once again, we have the same number in a numerator and denominator spot. So those can simplify all the way down to 1. 9 and 20 don't have any factors in common. 9 has 1 and 9, 3 and 3. 20 has 1 and 20, 2 and 10, 4 and 5. So the only factor they have in common is 1, and we already know that 9 divided by 1 is 9, and 20 divided by 1 is 20. So these two numbers can't simplify. So now I can multiply straight across. 1 times 20 is 20, and 9 times 1 is 9. I could leave it like this, but I won't get all of my points. Again, this will be like a 90% of your points because you're so close. But let's go ahead and turn this back into a mixed number so that we can get all of our points. We're going to use long division to do that, and I'm just going to write it up here. 9 won't go into 2, but it'll go into 20 2 times. 9 times 2 is 18. And 20 minus 18 is 2. So my answer is 2 2/9. Because I already simplified, I don't need to simplify now, but I always like to check. Can 2 and 9 be simplified? Again, no. 2 is a prime number, so the only factors it has are 1 and 2. 9 has 1 and 9, 3 and 3. So the only number that they have in common, the only factor that they have in common is 1. So this is in its simplest form. Okay, so we've done numbers 1 and 2. Let's talk about number 3. Number 3 says 5 times 3/8. Something to remember about whole numbers is that they all have an invisible 1 underneath them. Okay, so now I've made this into an improper fraction just by putting it on top of 1. I can't simplify any of these. 5 and 8 don't have any factors in common except for 1. 1 and 3 don't have any factors in common except for 1. So I can just jump straight into multiplying straight across. 5 times 3 is 15, and 8 times 1 is 8, or 1 times 8. Okay, so I have an improper fraction. I want to turn that into a mixed number. So that's 15 being divided by 8. 8 won't go into 1, but it'll go into 15 one time. I almost put 2 times. That would be wrong because 8 times 2 is 16, which is larger than 15. And 15 minus 8 is 7. So my final answer is 1 7/8. I've given you all the tools you need to succeed, so go ahead and do 4 and 5 on your own.